already? Okay. Okay. So today we are going to do more practical. Okay. So briefly, what we discussed last time was EEG recorder setup. And we also did a practical in IIT Delhi. Vicky, do you have any question on that? You were asking me something on RNet, right?
Yes,
On the
ma'am. It is clear, I think. So we discuss impedance check, and I know now that.
yeah. So you were asking whether RNet is 1010 or 1020, right?
Yeah,
So
because I was just checking on the manual available on their
it
website,
depends
medical
on
website.
number of electrodes. So if you have an RNet which has 128 or more, that is likely to be 1010. If it's 32, it is likely to be 1020. 64, you should check. It should still be 1020 in my opinion. If you have more number of electrodes, then you go to 1010 because you need more space. Okay,
Okay,
so
so which means the more electrodes, more number of.
so you need 1010 because then you need to utilize all the gaps in between that we had between 10 and 20, right? So that's why. So RNet in general would have either 1010 or 1020. If you had 64, it should be 1020, but double check that in your, we had taken those
Okay,
printouts, right? Yeah,
for
check that.
64 electrodes, it should be 1020.
Yeah, that's what I feel. Yeah.
Yeah. Okay.
Yeah. So, okay, so we discussed all of this and we saw some EEG signals. So today's agenda is for you guys to really understand frequency, signal frequency. So we have to understand sampling rate and we have to understand signal frequency. If you do that well, I think that is what majority of EEG is all about, signal frequency and the shape of the signal, etc. So we're going to go slow and we have to do some demonstration on Jupyter Notebook. So later on, you guys can download that notebook. I'll send it to you and use it by yourself and play around with the parameters. So that's the agenda for today. So first thing first, we have to first understand sampling rate. So sampling rate has nothing to do with the shape of what you obtain, shape of your signal. It is only about how fast are you measuring something. Okay, it's a general term. If you are taking a sample X number of times in a second, your sampling rate become X hertz. So this, I'm giving you 3 examples here. Can you see my screen? You can see my screen?
Yes, ma'am.
Yeah. So let's say I did an experiment and I measured something. Forget EEG. Let's say I measured anything. I measured it 4 times. So you can see these 4 dots. Only 4 times in 2 seconds. Okay. So what is my sampling rate then? If I measured something 4 times in 2 seconds, this is in seconds, and these dots denote the measurements. This is something I measured 4 times in 2 seconds. So what is my sampling rate here? Shilpi? Yeah.
Basically, sampling rate we discuss for every second, like up to 250 samples you mentioned of measurement.
That is one thing. That is information. Do you understand what sampling rate means? We are trying to understand it deeply. What does it mean? So if I made a measurement 4 times in 2 seconds, how many measurements did I do in 1 second? एक सेकेंड में 2 सेकेंड में 4 बार किया. So 1 second में twice we did 2.
Yes,
So your
ma'am.
sampling rate becomes 2 hertz. Shilpi was saying something. So if I did 20 measurements in 2 seconds, then how many times, what is my sampling rate? If I did 20 in 2 seconds, what's my sampling rate? Yeah. So sampling rate becomes 10 hertz. So in 2 seconds, if I did 20, so you'd see here, in 2 seconds I did 4, 1, 2, 3, 4. So in 1 second I did 2. So my sampling rate becomes 2 hertz. So if I did 20 in 2 seconds, in 1 second I did 10. You'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my sampling rate is 10 hertz. So if my and on the y-axis, what we have is value of something. So if we are doing measurement, the dots where they are in terms of x-axis is how many times and when did I measure it, and y-axis shows what is the value. So if we are doing EEG, what is the value in volts? What is the value, right? So if you did only 4, say let's say 2 hertz, you'll not be able to tell the shape of the signal, right? It's really not clear because you couldn't see the shape nicely. Itna kam measurement mein it's not clear to tell, especially if you have EEG signal. So in 10 you can start to see shapes, but it looks more like triangle, right? So if you go from 2 to 10, so this is like that. So then I can increase it, and here I've taken 200 measurements in 2 seconds. So what is my sampling rate now?
100.
Yeah, so 100. So then you can clearly see the shape of the signal. Okay, is this clear?
Yes, ma'am.
Vicky, is it clear to you?
Yes, ma'am.
Pakka?
I'll revise it myself.
You'll revise it later, but it has to be clear. So it's just about how many times we are taking measurements. So this distance that you see in your measurement. So first data I took here, then I took here, and so on and so forth. So we took 20 measurements. In 1 second, we took 10. So whatever number we take in 1 second becomes your sampling rate. So and so forth. The more data you observe, the better you will be able to tell the shape of the signal. Now, signal frequency is related to the shape of the signal. So whatever you have collected here, it looks like a snake, right? So signal frequency is how many peaks do you see of the signal in a second. So even though your sampling rate was 100 hertz, in 1 second you see 1, 2, 3 peaks. So your signal frequency is 3 hertz. Is that clear?
Ma'am, can you please repeat it?
Yeah, so you sampling rate is number of data points we are observing per second, and you're measuring something, right? You're measuring something. You're measuring that something that you're measuring is in the y-axis. It's called the signal. In case of EEG, we are measuring in microvolt, which is the signal of the which is the voltage of each electrode. So imagine you had one electrode, so you're measuring the signal for that particular electrode, and in the x-axis you have time. Now, sampling rate, you understand in 1 second how many data points did I take. So all these small balls here show you the number of observations that you made. That is your sampling rate. Signal frequency is related to the shape of the signal. If your signal has a repetitive pattern, how many peaks do you see in a second? That is your signal frequency. Okay, so here you see 1, 2, 3 peaks. So your signal frequency is 3 hertz. Clear?
Yes, ma'am.
Yes, ma'am.
What is the signal frequency here?
5, ma'am.
5, 5. In 1 second, how many
Ye-
peaks do you see? This is 1 second.
Okay.
One,
So second, one peak.
No, 0 to 1 second. How many peaks?
3 peaks.
3 peaks. So this is still the
Yeah.
signal frequency is 3 hertz. Here also is 3 hertz. The only difference is you taken more data so you can see the curve nicely. Here you took less data so it looks more like mountain. This looks more like we call it sinusoid, or more like a wave pattern. Right. So these two things have to be very, very clear. Otherwise, we can't proceed with anything else. Oscillations, rhythm, all of these are related to the fact that your brain has a repetitive pattern. Your brain, your breath, your nasal cycle, your blood pressure, everything is repetitive in nature. It goes low to high to low to high. So it has a rhythm or a pattern. And most of what you will care about is how many times per second, how many peaks per second, even if you do HRV. So if these things are not clear, you have to stop, understand, spend a lot of time and understand this, then move forward. Okay, so this is This is important. So these I'm just going to go do some lingo, and then we'll move to the Jupyter notebook and try to see in terms of how to play around with these things. So you will see these things when you deal with EEG studies. Some people will say brain wave, some will say rhythm, brain oscillation, right? Heard all of these?
Yes,
Anything,
ma'am.
anything else have we heard? Or kuch hai? I might have missed.
No, ma'am, that's all.
That's all. So rhythm means any regularly recurring motion. So something that sort of repeats its pattern. That is what a rhythm means. We understand. Like music, we talk about rhythm, right? The sound goes from low to high pitch and then high to low again. So that's what a rhythm is. It's just any regularly occurring motion. That's called rhythm. So there's some symmetry. Oscillation is little more scientific. It means that there's some kind of mean value, some central value around which it goes up and then it goes down. Then it goes up and then it goes down. And this is a pure mathematical signal. That's why it looks so clear. But in EEG, it's not as good. It's going to be like somewhat up and then down, then little more noisy and stuff like that. Then the multiple types of frequency imposed on each other. So it's not as clear, but it is clear to understand from this. Oscillation means there's some value around which it goes up and then it goes down. It goes up and it goes down. Okay, so that's what oscillation means. So normally people, when they say oscillation, rhythm in case of EEG, it means pretty much the same thing. They're referring to the fact that it is a nature of the brain. We are not doing anything there. It's just how your brain is, just how your breathing is. Most of the biological system work in some kind of rhythm, which means in time, if we measure that particular thing, it will have a repetitive pattern. It will go up and down and in some systematic way. It's not going to do like, it's not going to draw a map of India if we are going to plot that signal. So it's going to do some kind of rhythmic oscillatory thing. That's why it's very, very interesting and it's useful to
So
understand
it's
things.
basically same. I think that's what you want to say. Brainwave, rhythm, or oscillation. We can send.
You can, yeah, for EEG, you can say they are the same things, but they mean slightly different mathematically. Okay, so yeah, in most cases, what we are trying to understand is if I plot EEG data, how many peaks are they making in a second? That is what is very important for EEG studies.
Ma'am,
Okay,
here it is in that graph. Uh, yeah.
yeah,
So in this 2 minutes, I think it is. It says that 2 seconds. In 2 seconds, there are signal frequencies 9. I think that's what how we count it,
you
because
count
it
it.
is
Yeah, so if it starts here, you can count the peaks: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10. Okay, 10.
So your frequency becomes how much?
It's 10 in 2 seconds.
Yeah,
Yeah. So frequency in 1 second you are asking, right? So
frequency is
one
almost
second.
1 second. Yeah,
Yeah, 5.
yeah. So it's 5 hertz. Great.
Oh,
And then there's some sampling rate which is related to see number of dots. You will have to count all the dots and then go up until 1 second. See how many dots. I think this was sampled at
How
100.
can we how can we count the sampling rate like this, ma'am?
Can't count. So you'll just know that your device is measuring at 500 per second. When you do mathematical analysis, you need to know that, right? So that is something that is in our control. This is not in my control. I mean, for some yogis, it might be, but it's not in my control that I'll show you a delta wave or a gamma wave or whatever. That is that is what you're measuring. How many times you're getting the data is up to you. That is up to the experimenter. We typically do at least 200 or 250 or something like that in EEG so that you can see the waves clearly. Okay. So this is just a motivating slide on if you if you're going to do any EEG study, if you're going to even read a paper, you have to understand frequency and the concept of frequency band. So frequency is, we just talked about signal frequency. It is number of peaks in a second. When we say band, we know that in real world it's not going to be like every second is going to make 5, right? Biological system has its own variability. It's depending on what you're doing, how you're sitting and all of that. Even if you're resting, it's going to change a little bit. So we talk in terms of ranges. We say if it's 0 to 4 waves in a second, it's delta. If it's 4 to 8, it's theta. And we'll come to the concept behind it, ki where does it come from, right? But for now, let's just, and if your eye closed and awake, it is 8 to 13, we call it alpha. So we talk in terms of bands, which means we understand that biological systems which are not going to give you pure frequency waves. So we are going to get something
Sorry
which
to
is,
interrupt.
yeah.
It means here like for delta 4 hertz is there, so which it indicates that like what we've learned, just the peaks, actually the 4 peaks are there, then we
Yeah.
call it delta.
It's so that's what I'm saying. So it doesn't have to be 4. It can be anywhere between 0 and 4. So sometimes it will make 1, sometimes it will make 2, sometimes it will make 3, sometimes make 2.5, sometimes something. So any of that I will call delta. So it is
So
in
there's
terms
nothing to do with sampling rate here.
no, nothing to do with sampling rate. Sampling rate is the measurement. Even if you took 100 samples per second, so here that's why I showed you this. Even if you took 10 samples per second and 100 sample per seconds, it is still 3 hertz. The sampling, the signal frequency is still
Yeah,
3 hertz in both
got it.
cases. You just have bad data, so you can't tell the shape nicely, etc. And here you can't tell anything at all. So this is very bad. Like don't take one measurement per second, which is why functional MRI takes one measurement per second. Is not good enough to tell you the oscillations and stuff like that. That is used for different
In
purpose.
RNet, how many measurements we take? It is 500 something you mentioned
We
default.
are allowed in our system, we are allowed up to 5,000. Because it's an MR compatible machine, we can take up to 5,000. I think the default was set at 250
Okay, 250.
a picture. Yeah, yeah, yeah. So
That's
250,
enough, I think.
yeah, 250, 500, good enough. See, you want to capture gamma wave, then you can go a little bit higher. Otherwise, um, otherwise it's fine. So yeah. So we talk about ranges when we talk about biological system, right? So we can't talk about one unique frequency for one state. We talk about range. So 0 to 4 is delta. It could be anywhere like that. Then theta is 4 to 8, and then alpha is 8 to 13, beta is this, and then gamma. So, and they relate to, so that's why frequency is very interesting, right? So interesting that the fact that your brain is giving you voltage of a certain frequency, that means something important. That is why we do EEG in the first place. So it gives you information about different states of brain function and consciousness. Okay, so it can tell you about stages of consciousness, like I'm showing here. It can tell you about stages of sleep. So REM sleep, S1, S2. We'll go into that a little bit more detail. I'm just motivating. I'm just trying to hammer it in you that frequency, if you don't understand, you don't understand EEG. It is very, very important. That is the most important thing when we're dealing with EEG data. So frequency is what we are going to be centralized on in terms of any analysis. Okay, and so it can reflect different cognitive states also. So the fact that you're solving a problem or you're watching something which is intense, that can also change your frequency. Okay, and you'll see a lot of pseudoscience people going around saying that you can change your frequency by doing this practice and that practice without doing measurements. People who do measurements are scientific people. People who don't do measurement and claim these things, they are propagating pseudoscience. So if someone is saying, I do this to change my frequency, invite them, check their measurement, and if their frequency is indeed changing, they are saying the right things. If it's not changing, they are just they're not being
Yes.
scientific about it. Okay, so I can imagine that some yogis are able to do it, but most people are not able to manipulate the signals in their brain. So it's an interesting thing to do. Um, then some pathological conditions also change your frequency. So for example, epilepsy changes your frequency. So there could be abnormal spikes in frequency. So those are the things. So then so that's why EEG is helpful the way it is. It tells you the state of consciousness. It tells you which sleep stage you're on. It helps you to diagnose certain kinds of ailments. And then it can also tell you some changes in cognitive tasks. So if you're doing certain task versus other, you can go into more gamma or more delta or more theta, whatever, right? So it is a very important concept. So
Ma'am,
here,
can we, sorry,
yeah, go ahead.
by looking at the EEG data, can we say that this is the delta or theta dominant at the moment?
Yeah,
Is it
you can.
possible? Because
Yeah.
how can we count the number of peaks? Because the data it's not like it's not telling for just 1 minute or 1 second.
No, you can parse it for 1 second. You can look for the 1 second window and see. That's exactly what doctors do. They don't have access to all the sophisticated coding, no? So they get these printouts in a sheet In that printout, they will have the windows, 1 second windows marked, and they will.
Okay.
In fact, the earlier EEG didn't come with a, that you didn't have computers. EEG was even before computers, so they used to be just printouts. And the
Okay.
printout would be, you've seen probably those red sheets with, I can Google it and show you actually, raw EEG signal.
Yes, ma'am. Sure.
Let me
That's
show you.
interesting.
They didn't have access to computers and codings and all of that, right? So, um, and they used to typically have like printout. I don't know how to search it, but I've seen it in person. It's like a red color sheet and with markings of, I'll try to bring it up next time maybe. I have
Okay, sure.
one. I have one for my mother. She did it, recently, and like I was trying to understand what is, but basically it will have grids. So like here you have grids, and it will mark 1 second. So the
Okay, so
doctors
we
would,
can count the number of peaks in a 1 second, then we can see.
yeah,
That.
not only count, they also, doctors are also, trained to look for abnormalities. Normally doctors would do EEG for pathological conditions. So they
Yes.
want to know if your brain is functioning properly. So maybe someone has a tumor or, something like that also can get diagnosed, and epilepsy for sure can get diagnosed.
Yeah,
Uh,
nuances are there basically, so we cannot tell about that.
yeah, so you can tell these things. You can tell, you can also train yourself to identify those things. You can tell. So this is what it will look like. So see, you can't in awake state, it's showing in samples, not showing in time, so I can't tell. But as sleep deepens, the number of waves would reduce. So you can see from here to here, the number of waves per second, at least that much you can tell, right? That here is like more number of peaks per second and slowly decreasing. So that much you can tell. And there's something called sleep spindle, and I'll show you next time. So today I
Yes,
just want you
yes.
to first understand what frequency is, then you can do
Yes,
these
ma'am.
things. Otherwise, it's, and then the second thing is amplitude, of course. What is, how big this is. So if
Then
you are,
why do you mention like the samples there, not the timing?
yeah, I think that might be from a paper, and they might have
The
discussed how
sampling rate, right? The 500, like they mentioned.
yeah, yeah, yeah. So we'll go to the coding thing, and then unless you do it by your hands, it'll be difficult to understand. But if you want to start coding and understanding these things, it'll be easier to understand. Okay.
Yes,
So I will show you. So this is a Jupyter notebook. What I did was I started Jupyter Lab. You start Jupyter Lab, you will see all the folders here, and you can go to the file and do new and then notebook. Okay.
the
So
Jupyter notebook, I can open, right? Direct.
yeah, you can do it later because I don't have that much time. So you can follow the tutorial and do it later. So you go to the file, new, and then do notebook. So something new will open up. It will say Python 3. So you do yes and select. So one new notebook will get opened up. Okay. And then you can
Okay.
start coding cell by cell. So I prepared some stuff for you guys. So you can just, take a look at it and do at your own pace, because here I'll be covering a little bit more. So first thing is to use certain packages. Packages are nothing but codes other people have written to make your life simple. Okay, so we don't have to write everything. They have done everything, and we just need to write small pieces of code and use it. So now let's understand a signal first. Okay, so let's think about, we are doing one EEG experiment, and we are doing an EEG experiment for only 2 seconds. Okay, we started the recorder and stopped it at 2 seconds. And my sample frequency was set at 2. So we only did 2 measurements in a second. So if I did a total of 2 seconds, I took 4 measurements only. I showed you in the plot also. Okay.
Yes.
So the number of data points is n equal to t times sampling rate. This is, I'm calling, you can call it sampling rate or sampling frequency. It's the same thing. Okay. So 2 times 2, 4 data I accumulated. Okay, this is clear. So
Yes,
number of
ma'am.
samples collected is 4. If I had done the experiment longer, if I had done the experiment for 10 seconds, so I would have how many data points? 20 data points. Okay, 2 per second into 10, so it becomes 20. If I did only for 2 seconds, my sample frequency was 100. So I would have collected in 2 seconds 200 data points. 2 into
Okay.
100, like that. Okay, so let's keep it at 500.
So
So we
200 is sampling rate.
yeah, sample frequency is sampling rate.
Okay.
Okay, so let's make it 250, which is what you generally use. Both of you will use. So in sample frequency is 250, which means 1 second you calculate 250 data points. You estimate took those many measurements. So in 2 seconds you took 500 data, right? So number of samples collected becomes 500. This is that's it. Like that's just literally one line of math. It's like 1 second में कितना तो 10 second में कितना. It's like that, right? So 1 second में you did 250 measurements, so 2 second में you did 500 measurements. As simple as that. Now next thing I'll do, this is for if I want to make any plots and want to see what it looks like. I'm going to create an array which is between 0 and 2 seconds, 0 to t, 0 to 2 seconds. And the number of data points is the same as this, right? 500 samples I've collected in 2 seconds. So I'm just creating an array like this. You can print it and see, right? And if I had, let's say 10 here, so you'd have collected 20 samples. So it goes from 0 to 2 seconds divided into 20 parts. That's how that is the time at which we did the measurements. Okay, so you can do it aram se and understand this. Keep playing around with these numbers until you really understand it. And until you really say you understand it, I'm going to do the next class. So this is the most fundamental thing. And then frequency is signal frequency is the next thing. Okay, so now we did this. Now I'm not doing any measurement here. So I'm creating a mathematical signal. Okay, so that I can explain the signal frequency to you. So I'm creating a mathematical signal of a wave. This you don't need to truly understand. You can just play around with it. So there's something called a sinusoid. You can Google it. It says sine wave, right? Sine wave. So you can read it. It's a periodic wave which has a mathematical function. Okay. And because it's a wave, it will have a frequency associated with it and an amplitude associated with it and a phase associated with, which is how EEG is like an impure version of a wave. This is a very pure wave because it has a mathematical function. Okay, so this is only for demonstration purpose that I'm going to explain to you these things: frequency, amplitude, later phase. So I've used a function. Here, this F here is the signal frequency. So you understand that I'm trying to create a signal for you. We have this sampling rate and there's nothing on the y-axis. I don't know what I'm measuring. So I'm creating it for you using a mathematical function. Okay, the formula goes like, this is for a sine wave. Amplitude times NP is this library that I'm using, which is to use the sine mathematical function of sine. It's in the calculators also generally. Sine would be there in scientific calculators. And this is the formula 2 pi signal frequency times time. Okay, so whatever time it is, it's going to give you a value in the y-axis, value of the signal. So I do that and then I'll make a plot. So a plot comes up. What does it mean? So it means I had used f equal to 4. So I was asking it to take these many samples, 500 samples, and create me a wave which has an amplitude of 1. So here it goes only up till 1. And it has a frequency, sampling frequency of 4. So you'll see 1, 2, 3, 4 peaks in a second. Okay. Now if I make it 1, let's make it 1. I want to see only 1 peak in a second. So I've created, let's call it SF, so it will be more clear. This is signal frequency. Okay, 1 in hertz. And let's do that. Amp means amplitude. Equal to 1. So I've made the amplitude 1. I've kept the signal frequency at 1. I'm creating a plot for this. So now in 1 second, you have only one peak. Okay. I can make it 2. So now there's 2 in a second. Okay. And so on and so forth. I can make it 10. Okay. So now you see, if you're going to do, if you have a funny signal which has 100 peaks per second, your sampling frequency of 500 is somehow not going to be good enough. Okay, so you want better signal frequency to be able to capture that. So up until 10, it was fine. So let's keep it at 4. So 4 per second, we're sort of trying to mimic a delta here. And amplitude changes what? So let me change the amplitude. I make it 2. So it went up to 2 in y-axis. Can you see that? I can make it 100. It will go up until 100. Nothing changes in the frequency. If I'm changing the amplitude, only amplitude changes.
Sampling frequency is signal frequency, right?
Yeah, sorry, signal frequency. So signal frequency is 4, amplitude is 1. So there are 4 peaks per second. Amplitude so shows how far it goes when at the peak. Okay, the value at the peak in the y-axis. Okay. So you can keep playing around with it. If I can make it 2, leave this signal frequency the same, make it 2. This will go to 2. Peaks are still 1, 2, 3, 4 per second. Okay. And then, so like what else do you want to change here? Make it 6. So now they're 1, 2, 3, 4, 5, 6 per second. You
Okay.
can have fractional also. You can have it.
6 signal frequency in 1 second.
Yeah.
Amplitude 2.
Amplitude is the height of the peak.
Okay.
Height of the peak. And then if you can take a correspondence with breathing, right? So there are two things. You can breathe slow or fast. If you're breathing 15 times a minute, so your breathing frequency is 15 per minute. But it is also that you can do 15 in a very slow way, or you can do it in how much amount of air are you drawing in each breath? That is sort of related to your amplitude. Okay. So if someone had a very small nose, even if they're doing 15 per second, the amount of air they are taking in is less. And someone had a big nose, or they will be inhaling more air. So that is more like the amplitude. But how many times per second is, do you see the peak? That is the frequency. That is the signal frequency.
So, ma'am, why it is mentioned here like a signal? It should be amplitude instead of signal.
Where?
And the y-axis.
Because the voltage of the signal, it says signal in volt. That's how you will see most of the plots. They're not going to write amplitude. They might write amplitude, but most people will write the signal. So this means signal strength. Signal there are multiple names. It could be signal intensity. It could say, because amplitude is only at the peak, right? All these values are also of the signal. Amplitude is only the value at the peak. And it is very important, the value at the peak. But all of these data that you collected, they're all calculating signal. But what you're actually measuring is voltage, like we discussed, right? So it's signal voltage. Normally people will write, ideally they should write voltage. If it's an EEG, I'm just giving you some demonstration, right? And frequency is number of cycles, that number of peaks that you see per second. And amplitude is the height of the peak that you note. Okay. So I'm not going to go too much into depth here. I want you to download this notebook I'll send you, and
Sure.
keep playing with these things. Keep playing with sample frequency and signal frequency, and until you really understand it. And then when you say I understood it, then we'll do the next class. And
Sure.
then I'll explain to you what Fourier transform means, and couple of more things before we understand those things. Okay, so
I'm getting confused again with the terminologies. Actually, sometimes we say sampling rate. Now you said the sampling frequency and signal frequency.
sampling
Just
rate
use.
and sample frequency are the same thing. Number of samples you are
Yeah.
drawing in a second. Okay. Sampling rate and sampling frequency are the same thing. Sampling rate is mentioned in hertz. You can call it sampling rate. You can call it sampling frequency.
Okay.
Yeah, so you can, you take your time with this. Don't rush. Take your time, understand the concepts. You can Google, you can use GPT, but understand these two are different things. How many times you're collecting a signal is something very different from what the signal looks like. It may not even look like this. You can have a signal which is just going up like that. So
Yes,
in
ma'am.
that case, if it's not a rhythmic signal, there's no signal frequency, there's no signal amplitude. It may be a very different kind of signal. Okay, so but sampling frequency is related to any measurement that you did. How many times are you measuring something? That is what it is. It can be also called,
How many times in a 1 second?
yeah. Okay.
Thank you.
So I'm going to stop here. I'll share this notebook up until this part. I've created a function that does the plotting for you. So you don't have to, but you can check what I'm doing here so that you understand. Later on, you can play around with those parameters also. But here, as you keep changing these things, see how your plot changes and try and understand it. Okay, so this is a demonstration thing. So you can just play around in your Anaconda. And if you get stuck, you can let me know.
Sure.
Yeah, so I'll just give me 1 second. I'll copy these things and ensure that it's still working because there's more stuff in this notebook. I don't want to send you this. It will be confusing. And write some things for you. So can be also called sample rate or sampling. You can take notes in Jupyter Notebook, by the way. You can take like really detailed
Yeah.
notes. Like I've given the title here, but you can write bullet points.
The same thing we do in the R as well. Like we use hash because
Yeah.
it does not consider it as a code.
Yeah. So you can basically copy. I don't need to have both PPT and the Jupyter Notebook. I can actually just keep these notes here. I'll put them for you.
But it does not look good than PPT.
No, it look good. It will look very nice. You can do formatting and all that. I'm leaving in the window so that you start learning how to use notebook also. Okay. So create a signal array and then I'll put the stuff on this part. It looks very nice. You can actually print out with, code also. So it's nice that way. See, it's pretty decent. You can do the headings. You can, in fact, you can do, it creates a table for you to navigate. If it's becoming very long, you can just click here and go to that or that, right? Put a heading for this also. A code that plots signal.
This can be saved in cloud as well, I think.
Yeah, and then you can do a heading here. Import relevant packages. Okay, so now you can see all these headers are being created. You can just click here and go. Okay. So we did create a signal array, printed total number of samples. And then let's go here. A sinusoidal signal to understand frequency and amplitude. So now we'll do the plotting. Okay, so it's working, and you can keep changing it and plot different things. So you can plot them together. You can keep this here, and you can plot another one, say like this with two signal frequency of 2 and amplitude of 1.
Okay.
Okay, you can play around with that. So this much I'll send you, and then we'll do more later. So I'll just rename. So here it shows you the folder structure. So I just created this notebook. It's called Untitled. You can right click on this and do rename. So I'll do tutorial 1 EEG, and that's it. And if you're done working on it, you can right click and do shut down kernel. But until you keep it on and don't shut it down, all the variables are going to be in store. If you're going to shut it down and restarting it, you have to run all the cells above it. Same as R, like it's the same everywhere. Okay, so I'm going to email you this.
Sure.
And then if you have any problem, I'll show you how to download 1 second, so that you don't get stuck with this. Notebook for I'm attaching this. It's on my desktop. EEG tutorial 01 EEG. This is what the one, right? Yeah. So it will come like, oh, sorry, I have to send it to both of you. I've only sent it to Shilpi. So once I've sent it, so now I'll show you how to download and start it, okay? So that you can get started. So I'm closing this one. Shut down. I'm closing this, I'm closing this. And now I'll show you, I'll launch a Jupyter Node Lab from here. So I'm opening Anaconda. I opened Anaconda here. It's going to open up. In the meantime, I'm downloading this. So this is how you'll do the process, right? So you will not have it. So you'll download it. You download it. I'm downloading it in my downloads. It's tutorial 1 EEG. It's getting downloaded. Or you can create desktop. You can create a new folder and say EEG tutorials. Create and download it there. Save. Okay, now I have my Anaconda. Remind me later. What's this? Here you see the Jupyter Lab. Do a launch here. So it's launched. Now you can see your icons of your desktop. So I did on desktop, I created this EEG tutorial folder, went inside, I downloaded the notebook that I sent you, and it's opened up. And you have to now, if I just run this, it will give me an error.
Okay.
No, this is
Good.
this is not going to give you. There's no library that I'm using, and the whole thing didn't get saved. So interesting. So I'll send you a revised one. This didn't, before saving, I probably sent you. So, but anyways, you can download this. So you can download this. This is working. This is working. And then the plotting part didn't come, right? The sinusoid part. Yeah. So I'll send you again.
Sure.
That's what happens if you don't save it now properly. You need to save. There it is.